Hi, class. Today we want to discuss the discovery of the atomic model. We will discuss the Greeks' early ideas about matter, Dalton's atomic theory, and the discovery of subatomic particles. At the end, we will show what the current atomic model looks like. The early view of matters was relatively simple. Greek philosophers in 400 BC thought that matter was composed of only four elements: earth, water, air, and fire. However, one of the Greek philosophers, Democritus, had a different view. Democritus thought that matter is made of tiny, indivisible, indestructible particles. He called these particles atomos, which means indivisible in English. Unfortunately, Democritus did not have the necessary equipment to test his ideas at that time. Therefore, his ideas were eventually rejected. The next one is Dalton's atomic theory. John Dalton was an English chemist. He studied numerous chemical reactions, making careful measurements and observations. He came up with a theory called Dalton's atomic theory. There are four main ideas in his theory. The first one is, all matter is composed of small, indivisible particles called atoms. The second is, all atoms of the same element are identical in mass and chemical properties. The third one is, in a chemical reaction, atoms are not created or destroyed in chemical reactions. The last one is, atoms combine to form compounds in simple, fixed, whole number ratios. This picture shows one of Dalton's ideas. In a chemical reaction, atoms rearrange into new combinations. However, nowadays we all know atoms are not the smallest particles. They are divisible and are made of smaller particles, including electrons, protons, and neutrons. But how were these smaller particles discovered? Thomson was an English scientist. He was experimenting with gas discharge tubes when he noticed a movement in the tube. He called the movement cathode rays. The rays moved from the negative end of the tube to the positive end. When he held a negative metal plate near the cathode ray, the ray was deflected away. No matter which gas he put into the tube, he always made the same observations. He realized that the rays were made of negatively charged particles, which he called electrons. He discovered electrons. Thomson realized that electrons carry negative charges. At the same time, he also knew that most of the matter around us was neutral. Therefore, atoms must contain positive particles that balance the negative charge carried by electrons. Thomson proposed an atomic model called a plum pudding model. In this model, an atom is like a positively charged pudding, with negative electrons evenly distributed throughout, like plums in the pudding. After the electron was discovered, scientists wanted to know if there were other small particles within an atom. Ernest Rutherford conducted a famous experiment called the gold foil experiment. He used a thin sheet of gold foil and hit it with positively charged alpha particles. He expected alpha particles to go through the foil with little or no deflection. Rutherford's experiment results show that most particles passed straight through the foil as if it were not there. Some particles went straight back or were deflected as if they had hit something. Rutherford reasoned that atoms must contain a small, positively charged, dense nucleus and are mostly empty space. He called the particles in the nucleus protons. Based on his findings, Rutherford proposed a nucleus atomic model where an atom contains a very dense, positively charged nucleus. If an atom were the size of a football stadium, then the nucleus would be like a football in the middle of the stadium. This shows that although the nucleus is extremely small in size, 99.9% of the atomic mass actually concentrates in the nucleus. The next subatomic particle discovered was a neutron. It was discovered by James Chadwick in 1932. Chadwick used a setup similar to Thomson's cathode ray tube and discovered a new particle that had about the same mass as a proton but with no charge. He called it a neutron. Chadwick was awarded the 1935 Nobel Prize in Physics for this discovery. This is significant because the discovery of neutrons laid the foundation for nuclear fission and the development of nuclear bombs. Here is a picture of a modern atomic model. Atoms are made up of three types of subatomic particles: protons, which are positively charged, electrons, which are negatively charged, and neutrons, which have no charge. Protons and neutrons are located in the nucleus, which is the center of the atom, while electrons orbit the nucleus. I hope that this is clear to you. In our next lesson, we will practice calculating the number of electrons, protons, and neutrons for any atoms or ions. See you in the next lesson.